So this is the final idea of vectors, which is about how to find intersection points or how to use intersection points to find stuff about vectors. So as I was saying in 3D space, in 2D space, first of all, if two vectors are not parallel, they will always meet somewhere. I mean, if they're parallel, that's the only situation that they don't ever meet. But that's only in the 2D world, right? Because you
Right.
cannot draw a vector that is not parallel but still never meets. It's impossible.
Hmm.
However, in the 3D world, so in 3D space, it's actually very possible and common that two vectors that are not parallel still never meet, which is impossible in the 2D world. How? If one vector is up here and the other vector is down here, even though they're not parallel, they won't ever meet, right? Because this guy is downstairs and this guy is more like in the upper floor. So they're never going to meet. So these are called skew lines. So skew means not parallel but non-intersecting. So, you know, try not to remember it verbally.
Hmm.
Visually, it's much easier to kind of imagine this. So just two pencils that never meet because they're on different, like, heights above the ground.
Okay.
So it's given that you have two lines with these vector equations. Now, as I told you in the last class, the parameter can be any letter, okay?
Yes.
So in calculus, they sometimes even use delta or something, and that can throw people off. But they can
Mm.
literally just, they're placeholders for a thing that can be anything, okay?
Right. Okay.
So there are two vector equations. This part tells you about the initial point, and
Mhm.
this part tells you about what?
The direction vector.
Exactly. It tells you the direction. Okay.
Right.
Now, let's say that they meet somewhere. Okay. Now, the thing is, if these two vector equations belong to lines that meet somewhere, that means that at some lambda and mu, some very specific lambda mu pair, there is a point on both of these lines that's the same. You see what I mean? So
Yes.
x, y, z, right? That's what R is.
Yes.
If I plug in a special value for lambda and a special value for mu, maybe, by a stroke of luck, the x, y, z values for both of these vector equations ends up being the same, which means they are at the same exact spot, just for that one lambda mu value. Okay?
Okay.
So our goal is to find out when are the R values of both of these equal. In other words, just set them equal to each other and ask yourself, what's the lambda and what's the mu value that causes this to happen?
Okay.
So what we do is, by the way, I'm going to write them in column form, column vector form, because I like
Mhm.
that. -1, -1, 1. And I want this to be equal to the other one. 2, -2, 1 plus mu 1, 2, -7. Okay.
Yes. Okay.
Now, the first thing, by the way, this skill that I'm about to show you, very important. We already came across this when I was showing you how to parameterize equations.
Mm-hmm.
You need to convert each row into a separate equation, okay?
Okay.
So you would say 1 minus lambda. So 1 plus lambda
Right.
times -1 equals 2 plus mu times 1.
Mm-hmm.
So what's the second equation going to be according to you?
-2 minus mu
No,
or
that's
what?
lambda.
Okay, minus lambda, and
Hmm.
then it's gonna be -2 plus 2, and then that's what, mu.
Yeah, that's mu.
Okay.
So, oops. By the way, if you look closely, it looks like an M. I feel like
Okay.
that might be where the Latin M came from, but I don't
Okay.
know. So,
Um,
yeah, what's the
negative
last one gonna be?
-4 plus lambda
Hmm.
equals to 1 minus 7 mu.
Exactly. Three equations, but here's an interesting situation. In mathematics, we call a situation like this over-constrained. Why is it called over-constrained? Do you have any idea?
No.
Look, every equation is basically a constraint. Okay. What
Okay.
on a constraint on what? On what lambda and mu can be. Okay.
Yeah. Okay.
If I only had this one equation, then there is not enough constraints on lambda and mu. So lambda and mu can be anything. But when I
Right.
have two equations, then, and since I have only two variables, two equations is a sweet spot. Now I can use these two equations to find out exactly what lambda is, exactly what mu is. Okay.
Okay.
That's what we've always done, simultaneous equations.
Mm-hmm.
That would be perfect. If I had only one equation and two variables, that would be under constraint. But I have three equations and
Okay.
only two variables to find. This is called over constraint because not only do I need to find lambda and mu using my regular two equations, the
Mm-hmm.
solution of my lambda and mu also needs to satisfy this third guy who was just watching the whole time.
Right.
So he's giving me an extra constraint to worry about. So not only do I need to find the lambda and mu, I also need those lambda and mu to satisfy this third line. Because I want all the x, y, and z to be the same on both, right? If I just like solve these two together, that'll give me only x and y.
Yes.
Yeah. So I need to solve all the three of these simultaneously. Just
Okay.
pick two of them to work with in the beginning. So I'm gonna
Mm-hmm.
basically use elimination. So I'll bring mu and lambda to one side of the equation
Okay.
and this. So what I did was I added lambda to the right side.
Mm-hmm.
So I have lambda plus mu now. And I subtracted 2 on the left side, which would mean I have 1 minus 2, which is negative 1.
Yes.
Okay. Can you
Got it.
do a similar situation to this so that I have lambda and mu on the same side?
Yes. So I would do negative lambda minus, I like to do it in steps, so minus
Hmm.
2 mu equals to um 0 because it's negative
Exactly.
2 plus
So
2.
I would just cancel it out immediately. The moment you see the same thing on both sides doing the same thing, I just
Yes.
cancel them out, right?
Yes.
So now, what do you do now for elimination?
Negative lambda equals negative mu equals to 0 divided
Uh,
by 2
Negative lambda what? Negative lambda minus 2 mu?
minus mu equals to I to get rid of the 2, right?
Hmm. No, no,
Negative.
no. So what I'm going to do is I'm going to add these two equations together because if I add
Oh,
these two, they will cancel out. I think you were
right.
going for substitution, it seemed like. I'm not
Okay.
sure. But yeah, when you add these two equations, these are going to cancel out and you end up with mu minus
Mm-hmm.
2 mu, which is just minus mu, minus 1 plus 0, which is just minus 1, which tells me
Mm-hmm.
that mu is.
Um, hold on. I wasn't
Okay.
yeah, I was trying to do a substitution. I was trying to
So you were trying to make lambda the subject and then plug that
yeah,
over here. Okay, that
exactly.
works too, I guess. But I saw these two having opposite signs and the same coefficient, so I was,
Okay, so
I'm
mu
lazy
is
like that.
1,
So
right?
one, mu
Yes.
is 1. Exactly. So now, can you find lambda using one of these two equations?
Yes. Um, okay, so now I just plug in the 1, right? Lambda is negative 1 minus 1, so negative 2.
Now that my first two equations are telling me that the x and the y will be equal if mu is
Right?
1 and lambda is negative 2, I
Mm-hmm.
need to make sure that z is also equal in that case.
Okay.
Okay? Because
Mm-hmm.
look, by solving these two equations simultaneously, I found out that when lambda and mu are this pair, the first equation is satisfied and the second equation satisfied. The
Okay.
first equation being satisfied is that tells me that the x value of the first vector and the x value of the second vector will be the same
Right.
at these lambda mu values. The second equation being satisfied means that the y values are going to be the same. But I
Mm-hmm.
need to now also check that the z values are also equal if I plug in these lambda and mu values. So
Yeah.
I plug in lambda for minus 2 and I plug in mu for 1
Mm-hmm.
and it looks like I am in luck because 1 minus 7 is indeed minus 6, which tells me that z1 is indeed equal to z2.
Right. Okay.
So for these lambda and mu values, after checking, of course, I can
Mm-hmm.
claim that when mu is 1 and lambda is negative 2, r like basically we can say r1 equals r2 basically if I go back and say that this is r1 and this is r2.
Yes.
Okay.
Okay.
However, that's not what they asked for. They said find the point where they meet. So now all I gotta do, what do you think I will do, by the way, to find the actual point where they meet?
Um, equal to 0.
So I'll plug in either mu equals 1 into the second equation or
Okay.
lambda equals negative 2 into the first equation. Both of them, by the way, will give me the same answer because again, they're at the same point there.
Okay.
But just to show you, so this is my first equation, right? R equals this, and this is R equals this, two separate equations.
Yes.
So I'm gonna plug in lambda equals negative 2, which gives me R equals, as you can see, 1 plus lambda times minus 1, right? So
Yes.
1 minus lambda. So 1 minus lambda would be 3, because
Mm-hmm.
1 minus negative 2 would be 3. And then the second line is minus 2 minus lambda. So
Yes.
minus 2 plus 2, 0.
Okay.
I'm doing this in my head. I hope that it's making sense. But I'm plugging in
Yeah.
lambda equals minus 2 into this.
Yes, I got
Okay.
it. And then
And
negative
then, yeah,
4.
finally, -4 minus 2, which
Mm,
is -6. And just to show you that it's indeed the same, I'll plug in mu equals 1 into the second equation, which will
okay.
tell me from the second vector equation, r will be 2 plus 1, minus 2 plus 2,
Mm-hmm.
and 1 minus 7 is -6. See, the r values are the exact same for this pair of lambda and mu. And
Okay.
that is how you can find out whether whether two vector equations ever intersect and where they intersect if they do. Now,
Right.
how would we find out that they do not intersect? You would
Mm,
write down these three constraint equations just like before,
okay.
and as you're going down usual business, you might even find lambda and mu. But
Mm-hmm.
once you find lambda and mu and you try to plug it into the third equation is going to say, hey, -2 and 6 is what I get, which means that the z values do not correspond, meaning they are on top of each other basically, because the z value is what floor you're on basically, right?
Okay.
Because if one of them says that my z value at the given lambda value is going to be here, and the
Mm,
other says my z value is here, even though the x and the y end up being the same over here, see, the x and the y values seem to be the same here.
mm-hmm.
See what I mean? So see,
Yes.
they're at the same floor, like they're above the same point on the floor, but they're on different floors. So they're on top of each other, so they never really meet. The z values never align.
Right.
Okay?
Okay. Okay. Got it.
So that's how
So
you would find out that they do not intersect at all.
would you say that the Z values are skew or
Oh, no, we wouldn't say the z values are skew. We would say the whole vector is skew or the lines are skew,
okay.
right?
Mm-hmm.
So basically, skew lines are any lines that have no point of intersection. Okay?
Okay.
But I mean, of course, and they're not parallel because if they were parallel, then this would be very useless. So how do you check that they're not parallel though? So parallel, very easy by the way.
Mm-hmm.
Parallel 3D lines or vectors because we're talking about vectors. So look, for example, 1, 2, 3. The other one would be 4, 8, 12. See, they're clearly parallel.
Mm-hmm.
This guy is literally 4 times the first guy. So
Yes.
they are parallel. Okay.
Okay.
But what
Mm-hmm.
if they're not parallel? I mean, by seeing that they're parallel, they of course they do not meet. Don't meet. But we
Yeah.
don't call them skew now because they're parallel.
Yeah.
Parallel, it's just basic knowledge that parallel things do not meet. However,
Yes.
what if they were not parallel but they still didn't meet? That would be skew. Okay?
Okay.
Because we
Mm-hmm.
need a third definition at this point because that's a special case.
Right. Okay.
So let's quickly do look at a situation where we have a skew situation, and I believe that'll be the last example you need, and we can move on to the next topic or the next course depending on what we planned that I've need to check.
Yes. Okay.
Remind me, by the way, what's the plan after this? Are we going for
So
uh, calculus?
yeah, first I think we would do the vector question, try to do it now. And then next is complex numbers.
Okay.
Yeah.
So, matter of fact, let me leave this for you as homework because
Okay.
I just realized it's the exact same process as before. Okay.
Okay.
So, literally the exact same. And you will just realize that when you get to this point, the Z values won't align.
Right. Okay.
Okay.
Got
Everything else up to this is the same. At this point, when the Z values don't align, you will claim that since these guys are not parallel to each other, clearly, the direction vectors are not parallel,
Mm-hmm.
okay, and they don't meet, that means that they are skew lines. You will find out that this will be skew because they don't meet, they're not parallel.
Got it.
Okay.
Mm-hmm.
So I think let's stop the recording here.